Welcome to the 100th installment of Ear to the Ground, the Land Stewardship Project's audio podcast on family farming, sustainable agriculture, local food systems, and local democracy. I'm Brian DeVore of the Land Stewardship Project. This podcast is the third in a series of 5 programs featuring a March 24th, 2011 presentation given in Creighton, Nebraska by Don Huber, a Purdue University Emeritus Professor of Plant Pathology. Huber's presentation describes his concerns about the long-term problems associated with the use of the popular Monsanto herbicide Roundup. In this episode, Huber describes the manner in which glyphosate, which is the main component of Roundup, alters soil biology significantly, and in the process makes valuable field crops more susceptible to disease.
I made the comment that you can't kill a plant in sterile soil by glyphosate. Bill Johnson and his group at Purdue in their publication this last summer made the comment it's a well-documented mode of action of glyphosate, but it's rarely cited. But this is the mode of action of glyphosate. First reported by Rahe and Joe Hall actually in 1984. Had this picture in 1988. We used it again in a paper that I have with Gurry, co-author from the European Journal of Agronomy. Use that picture again. As you can see, here's the no glyphosate soil, and here's where you put glyphosate on in a sterile soil. It can stunt. It's a growth regulator because the schimate pathways is secondary metabolism. But in 2 or 3 weeks, all those lateral buds will break, and you'll end up with a bush out there rather than just a stunted plant. So as the plant recovers those chelated nutrients, it'll again take off and grow again. But you look here in field soil, in 4 days, those plants have already collapsed. Those soil-borne fungi, very active, just waiting for an opportunity. We've tied the hands behind the back of that plant and just let those pathogens come into dinner. They demonstrated this also with a foliar pathogen. This is anthracnose on beans, Colototricum lindyumuthianum. We have another anthracnose on corn. You're probably all familiar with it on the Colototricum graminicola. But what they did, this is a very severe reaction to anthracnose. But you see, finally the plant's producing enough of those phytoalexins and antifungal compounds that it limits its growth. And you end up with that typical anthracnose-type lesion that you see, but it's limited because the plant's been able to limit its further development. If you put a dilute solution of glyphosate where these black dots are and then inoculate with the fungus, you can see that there's no defense. It's just a matter of time before the fungus has moved all the way across those tissues and macerated those tissues for its own utilization. I was at Purdue in December. I had a defensive thesis for one of Bill Johnson's students, PhD student. Said, well, if that's really the mode of action, we ought to be able to go in with a fungicide and eliminate the herbicidal mode of action of glyphosate. Well, she knew that Pythium and Fusarium and Rhizoctonia and Phytophthora are the common fungi that are the mode of action for glyphosate. We have individual fungicides that we can use for all of those to give some protection to the plant. So this is the one with Pythium, where she had it. First she, again, looking at 5 glyphosate-resistant weeds. In her study, this was giant ragweed. She had mare's tail, and she had pigweed and a couple of others there that she looked at, found the same thing with all of them. Again, seeing that effect here, and this is her glyphosate control. Again, it's stunted from what it would have been in a non-treated. Here's your Pythium control, because at this stage, anything above a couple of inches, those plants are naturally resistant to Pythium. So it's pretty hard for Pythium to control a plant that's well established. And yet you can see 4 days after treatment, you can see that plant's already on the way out with Pythium. Well, she looked at those and she said, okay, if I provide Ridamil, which is an excellent fungicide for controlling Pythium, I should be able to keep those plants healthy. And so she did that, and here you see where she had her Ridamil, where These are from her Pythium-infected soil, or infested. And you see there's no herbicidal effect there, just a growth regulator effect. Did this with the other pathogens. Find the same relationship, because this is the mode of action. You can't kill a plant with glyphosate and sterile soil. And she demonstrated that. Well, then she looked at her resistant plant. What's the reason for resistance? She finds they're all resistant to the pathogen. Ridamil didn't help any because they're already resistant. What we're doing with resistance is we're creating susceptible or super weeds that are resistant to these soil-borne pathogens. Then as we increase our rate of glyphosate 4 times or 10 times, as some of them are using in order to kill those, what we're doing is increasing the virulence of the pathogens. As Dr. Kremer showed, that 500% increase in root colonization. You may not be reducing the susceptibility of the crop or resistance of the crop as much as you're increasing virulence of the pathogen. You're also changing that soil biology for those organisms that normally control or give us some control through our management efforts of these soil-borne pathogens that we don't have good chemical or genetic resistance to. So we're changing the environment, we're increasing the virulence of the pathogen, and we're reducing the resistance of the plant. So we have 3 of those 4 points on that diamond that we've drastically changed when we continue to hammer in the same direction with one compound, one chemistry. They found that when they put all of these resistant weeds in the greenhouse, or that whole range of resistant to susceptible weeds that they'd selected, treated them with glyphosate, there wasn't any difference in any of them. There isn't anything in the technology that does anything to the glyphosate. All the technology does is maintain the level of resistance so that the plant isn't killed by the glyphosate. Resistance to the pathogen, not to the chemistry. These are the mode of action of glyphosate. Fusarium, Rhizoctonia, Pythium, Fusarium, or Phytophthora, Gomonomyces, Cornospora. How many of them are common pathogens that you have on your crops? Fusarium crown alfalfa, Rhizoctonia. Same thing on beans. We see an increase in severity on dry beans after we followed a Roundup Ready crop because we've created a super pathogen and changed the biological environment. Over 40 diseases that are recognized as being increased by glyphosate. We can increase that list. If you look at that thesis from Bill Johnson and his student Jessica Schaefer at Purdue, if you just take that thesis and if we were doing what we do on a crop plant, they've just identified another 10 or 15 new diseases that kill the plant if you use glyphosate. But since it's on weeds, we don't report that as a new disease. We're not interested in the diseases on the weeds unless we recognize what the mode of action is. But these are on our crop plants. Worked on and served on our threat pathogens committee, both through the DOD as well as more recently through USDA and the APS. We've looked at those emerging and re-emerging pathogens or threat pathogens, and I've been involved in that for over 36 years. And what we've been seeing the last 15 or 18 years, a lot of those pathogens that we used to consider very effectively controlled through our management practices, all of a sudden are out of control. We're seeing that curve take off in spite of what we're doing. Had a call from 2 growers in Kansas this last fall, said I need some help. 2 center pivots. Wheat yields were 8 bushel. Severe take-all. Can't put the diesel in the tractor to plant or to harvest, leave alone for anything else. Had one from Nebraska, south of you here. 25 bushel on a center pivot. They used to get 100 bushel. Can't get 100 bushel at least. Can't pay for your water and your fertilizer and your seed and your fuel. What's happening? Severe take-all. There's some things they can do about it if they recognize it, know what to do. And we've got some new tools as far as some of our nutrient. I was in England with Chris Wrigley and Neil Fuller here in December and looking at a lot of the things they're doing. It's some pretty phenomenal things we can do for these soil-borne pathogens to offset some of this effect if we recognize it and recognize what's happening. This is that earlier slide that I showed you. This is where we were looking at different herbicides as far as their effect on physiology of soybeans. Some are weed scientists, but we had all those plots located. So after we harvested the soybeans, we bulk seeded it to the wheat because we could locate all the plots, and then look for the effect on take-all. Here you see this plot here, just the corner, but you see that increased severity of take-all, predisposition by the glyphosate that was applied the year before. See the plot over here? Yeah, there's some take-all. Here's a white head. See some, but not near the severity. Tremendous difference in that severity of that disease. Dave Hornby, 25 years ago, reported that at Rothamsted. He said, anytime we use glyphosate as a burn down for couch grass or cheatgrass, we see an increase in severity of take-all the next year. You change that soil biology that gives us some biological control. Also greatly change the availability of manganese that's closely associated with resistance to this disease because of that lignification or suberization callousing on penetration. Field at the agronomy farm. No reason for it to be split in the middle. When we initially looked at it, got a call from our wheat breeder. Said, I want you to come out and explain why half my field has severe take-all and the other half doesn't. It's a research field. Had been the same crop rotation for 30 years. Crop sequence, same management. Part of it was tilled, all of it was tilled. Had corn on it, all of it had corn. Had Roundup Ready soybeans the year before. The whole field. Didn't make any sense. Jim's really careful, the station superintendent, to make sure that this doesn't occur on our research soils. We don't need another variable. You can see how severe it is, and we walked this, and we drove around it. You see here even some of them going down. These are early maturing lines here, so that when you shell it out, you still have a full kernel. You shell out these, and all you get is a bunch of chaff. Look at the roots, and they're all black, scurf up on the crown. Typical, real severe take-all. You look at these, and you'll see some nibbling, see some root lesions, lateral roots that are gone. Take-all's there, the fungus is there. How come the difference in severity? I couldn't come up with a reason. Herb didn't have any idea until we saw this flag, and I said, well, gee, here, you told us right off what the difference is. You put a flag there to mark it. You see it doesn't match the planter rows. I said, no, that's not my flag. That was the farm's, and we just didn't get it pulled. So we went in and got Jim, the station superintendent, and asked him how he could explain why half of the field was severe take-all and the other half wasn't. Said he didn't know. He's been driving around the field for 2 or 3 weeks trying to explain it himself. Want to know what Herb had done. I said, well, you got a red flag here. What's it for? He thought for a minute, and he said, we've done such a good job of weed control. We don't have a lot of weeds now. Glyphosate's been so effective, getting that seed bank down. But he said I had a few weeds show up in the soybeans up here. So I sent my crew out, take care of them. And he said I put a flag down here because there weren't any weeds down here and wasn't any need for them to spray the glyphosate. See it all the time. Epidemic of Fusarium head blight throughout North America, in fact, throughout the world. Say, how come? What's changed? I spent 6 years on a survey of Indiana, Illinois, Kentucky, and Ohio because I wanted to work on this disease, and I couldn't find enough Fusarium head blight to justify a program for my experiment station director. I could get 8% with direct drilled wheat into corn stubble down in the Posey County area in southern Indiana. I can take you to fields any time during the summer now, and I can show you 80% head blight. I mean neck blast. Not just the center of the head or the top or the base of the head, but the entire head gone. I can tell you in 1971 to 76, that was a rare occasion because you have to have precipitation, you had to have flowering, and you had to have 80-degree temperatures or above, all at the same time. Wheat flowers over a 5-day period. So that if you had the 80 degrees just for one of those days, you just get scab in the middle. When the temperature dropped, plant was resistant again. If it occurred later on, in that 4th or 5th day of flowering, you'd see the tips or the base that would be head scab. Same pathogen on corn for Gibberella stalk rot. Also seedling blight. When do you have seedling blight on corn? When you cool soils. Corn has the opposite relationship in that carbon-nitrogen metabolism as wheat does. Corn's susceptible at cool temperatures, and wheat's susceptible at high. Now, this is also a very severe root pathogen for us pretty much all the time. You don't need that temperature relationship for it. Wanted to work on it because Dixon had shown in 1953 that the effect of temperature is on changing that carbon-nitrogen metabolism. And I wanted to follow up. Couldn't find enough in that time period to justify a program on it. No problem now. When Carol Wendell's called, and I guess this would have been in, late 80s or 90s, USDA had put up a lot of money for head scab work. She's up in Crookston, Minnesota, and she said, "Don, what do I do for head scab?" I said, "It's a real serious problem for us. Been very, very sporadic all the time before." I said, "Quick and get your grant in. You may not see it for another 5 or 6 years. Every year, becoming more severe in the toxins that they produce." Dr. Fernandez done some really excellent work in Saskatoon. She found you still have to have the flowering and the precipitation, but you no longer have to have any of those other factors because you don't have to have the 80-degree temperature because glyphosate changes the physiology and that amino acid relationship for susceptibility the same as the 80-degree temperature did. What she found is that if you've applied glyphosate once or more in the previous 3 years as a burn down, you'll have an increase in severity of fusarium head blight. If you apply it every year, you can have a 300% increase in severity of that disease. And if you use a Roundup Ready crop like Roundup Ready canola, it goes up even more because you use more glyphosate, change that soil environment, and then the physiology of the plant in an indirect manner because you're not putting glyphosate directly out on the plant. Now, you may have residual glyphosate that can be desorbed and still taken up by those roots as another factor in here, but just changing the overall nutrient relationship can account for a lot of this effect. Cornospora root rot on soybeans. This is the number 2 disease in Brazil, next only to rust. Scott Abney described this disease or described the pathogen and its interaction with soybean about 30 years ago in Iowa. He was at Iowa State, and he showed it all through the Midwest. Said it's just a root nibbler, common soil organism, doesn't ever do any damage. We always figured it was never an economic problem. I've seen some yield losses up to 40%. You can see what happens. It can be a pretty good pathogen in inoculated soil. You can see a lot of root damage here that would certainly be reflected in yield. But look what happens when you put some glyphosate up on the leaves of those Roundup Ready plants, and you have some pretty devastating effects on that susceptibility to this disease. It's an emerging disease for it. One of those that we can watch for and anticipate continued increased susceptibility. But we need to make sure that we have the nutrient base there for our plants to maintain that resistance, to keep them going so we can harvest that resistance. Field in Iowa, and actually grower or the seed dealer had invited us there to look at his corn hybrids that he had out because he had a lot of difference in Goss's wilt. And so as we drove in, noticed that fairly straight line down there where he had severe SDS and very little SDS. And I asked him what he'd done. He said, "Well, I want you to look at my corn hybrid first," so he didn't want to get sidetracked onto the SDS. I guess he realized that my memory retention is fairly short here. But looked at his Goss's wilt, interactions there, and I'll get into that a little bit here later. We finally got back to the soybeans, and I said, "What did you do here last year that gave you this difference?" He said, "I haven't even noticed this. I drive in every day, and I hadn't even noticed the difference because he was involved with his corn so heavily." He said, "But I had some alfalfa here, and I put out 2 quarts of glyphosate burn the alfalfa out. In the fall, this was all in sweet corn on this side of the field because you had a little farm market up on the corner of the area and hadn't had any glyphosate for 3 years. I planted Roundup Ready soybeans, and they all got 1 dose of glyphosate in the summer. But you see the effect of that glyphosate in changing the soil biology from the year before or the fall before. Tremendous predisposition, and this is what you see. When we got up and had aerial photographs where you could see those soybean fields throughout the Midwest, you could tell right where a farmer didn't get his sprayer turned off when he put out his glyphosate application, and you'd see real severe SDS. You could track that based on how much glyphosate had gone out and what its effect it had on stimulating the root colonization of that fusarium and changing the soil biology. Very dramatic effect. Some work of Larson and the group at Fort Collins Sugar Beet Laboratory, been reproduced by several others. What they found is that when you put glyphosate out on a Roundup Ready sugar beet plant, you nullify the genetic resistance to Rhizoctonia. Well, it's pretty rough pathogens for crown rot. Not in every field, but certainly enough of them. Also, some varieties were showing increased susceptibility to fusarium, a little more erratic with the fusarium. But they put a precautionary statement out. You need to be careful if you have these soil-borne diseases because you can be more susceptible in a glyphosate environment than you would without. Well, you can compensate for that if you recognize what those micronutrients are that you need to maintain sufficiency for if you're going to go deficient or going to go into a less than optimum relationship, and you can beef that resistance back up if you recognize it. If you don't, then you'll be like the grower 20 miles south of me, brought his load of beets into the pit. He said, yeah, they were pretty heavily infected with crown rot. We didn't realize it in 2 or 3 weeks they'd start running out the bottom of the pit because he had lost that resistance, natural resistance, that we had spent years breeding into those beets. One of the real concerns with Roundup Ready alfalfa, we have a disease of alfalfa that can eliminate alfalfa, and that's bacterial wilt. All of our varieties have very excellent resistance. Clavibacter insidiosum, it's a sister to Goss's wilt. What we see with sugar beets could be a very, almost a picnic relationship compared to what it could be for alfalfa. I had 3 paired plots, 6 fields, or 3 fields with Roundup Ready versus non-Roundup Ready alfalfa. Only 2 of them survived 3 years of the Roundup Ready. Clavibacter insidiosum can take alfalfa out. Our resistance and our only control for that disease is genetic resistance. Goss's wilt on corn, when you put your glyphosate out, 6 of the 7 resistant hybrids became fully susceptible to Clavibacter nebraskiensis, a sister to the alpha bacterial wilt on alfalfa. Can eliminate a crop as a viable entity for us if we produce a super pathogen or if we lose our resistance. See here of those 7 hybrids, you can see 4 of the hybrids. Here's your control. Here's your surfactant control. And this is just with the surfactant from the glyphosate formulation, not even with the effect of the chemical itself adding to it. Here you can see the Clavibacter its own, it's pathogen, the pathogen in water. And Vitivar was asked, well, how come we have all this severe Goss's wilt? Hands at the University of Nebraska, the world authority on Goss's wilt, as well as Stewart's wilt and other bacterial diseases. So that's a really wimpy pathogen. It won't even penetrate through the natural openings of the plant. It has to have a wound. Yet we've had 2 years of major epidemic throughout the Midwest. In Nebraska, you've seen it for a long time. You look at the corn compendium, and we tell you that it's a localized disease in its severity. Normally, we would associate it with B14 or A632 inbreds. We found a few of those are probably in our current stock, but most of them are going to be one of these resistant line. You can see they're still resistant if you have a normal route of entry of that pathogen. Takes a wound. Can't get in. If you have a hailstorm, or if you have a really driving rainstorm and a lot of wind where you get those little wounds produced, that's when we used to see Goss's wilt severe. Now you see it all over the Midwest. 1 billion bushel shorter corn crop this last year. Not just the Goss's wilt, but it was a major contributor. If you look at the July estimates of the USDA on what our corn crop was going to be, and then look at what the actual harvest was, we're just short of 1 billion bushel. Where'd it go? Where'd your test weight go from 56 bushel down to 48, and sometimes 42? Are characteristics of Goss's wilt. How do you counter it? You have to use an alternate process, an alternate program. You're going to have to apply a bactericide to control a disease that shouldn't be a problem for us. It survives in your residue. You got plenty of it on the soil, plenty of inoculum there. You still have to have the environmental conditions. That's why it was much more severe where we had that moisture. Get a drought year, not going to be as much of a problem for us. But how are you going to control it? You have antibiotics, a lot of opposition, really adds to the cost. You're talking $60, $70 an acre as a minimum. That's for one application. What other bactericides do we have? Have an experimental one that looks quite good. Going to add another cost. You're going to have to get it on early, maybe more than once. We don't have a lot of alternatives. What are you going to do on your alfalfa? We don't have a lot of alternatives to bacterial wilt on alfalfa. Again, we haven't demonstrated it with alfalfa that it increases bacterial wilt on alfalfa. All I'm saying is that we need to have the research done before we jump off the cliff, because some of these things are irreversible for us, or pretty hard to reverse.
This podcast is dedicated to the memory of the late Terry Gompert, a University of Nebraska Extension educator and longtime sustainable agriculture advocate who brought Professor Huber to Creighton. Sadly, Terry passed away the day after Huber's presentation. For more information on Dr. Huber's work related to glyphosate, see www.landstewardshipproject.org. Click on the blog button and search the term Don Huber, that's Huber. If you have comments or suggestions about this podcast, contact Brian DeVore at bdevore@landstewardshipproject.org, or you can call 612-722-6377. Thanks to Laura Borgendale, a Western Minnesota musician, for Ear to the Ground's theme music. And a special thank you to all of Land Stewardship Project's members who make initiatives such as this podcast possible. If you're not a member, visit landstewardshipproject.org to learn how you can support LSP. Thanks for listening.